I'd like you to create a summary of what we should know about polynomial functions at this particular moment in time. So what we know is our standard form of our polynomial function looks like this. It's f of x is equal to a subscript n, which just stands for the leading coefficient, times x to the exponent n. N is the degree of the polynomial. It's the highest power in your polynomial function. It's the highest exponent that appears on the x term. Now, all of these exponents have to be whole numbers. You can't have any fraction exponents on your variables. You can't have any negative exponents on your variables. You can't have an exponent being a variable. So all of these things have to be true. When we write these polynomials in their standard form, we always want them to be written in descending powers of x so that we can see what the leading coefficient's value is, whether it's positive or negative, as well as what the degree of that polynomial is. Now, all polynomial functions are functions. They will pass the vertical line test. So regardless of what degree we go with, it will be, as long as all the exponents on the x are whole numbers, they will be functions and they will pass the vertical line test. So I'm just going to summarize those key points here under the standard form. All right, so I've summarized those key points there. I've also included an example of a polynomial function. Now you'll notice that this is not written in descending powers of x. If I look through my terms that I have here, I see that the highest exponent on my x is an x cubed. So that one should go first. So I am going to take that coefficient, which includes its sign of -2 with the x cubed. It goes first. The x squared term will come next, and its coefficient travels with it. And then we have our plus 4x, and then the constant term will always be the last term. So this a0 up here, this is your constant term, which turns out it will always be your y-intercept. We talked about that with parabolas. That's a constant. It will be your y-intercept. It is true with parabolas. It's also y equals mx plus b. The b part, the constant number, that is your y-intercept. That's always going to be true for our polynomial functions. So all the things we've learned about linear functions and quadratic functions can now be extended to these higher degree functions. Speaking of degree here, it's the highest exponent on that independent variable, the variable of x. So the function I just drew above here in green, that is a cubic function. It has a degree 3, so it is a cubic function. So this is degree 3. It's cubic. And if we have degree 4, it's called a quartic function. All right, now it's important to know whether that degree is an odd number or an even number, because the end behaviors will be different depending on the degree. An odd degree function, odd degree polynomial, will have the highest exponent on the x being an odd number, and an even degree polynomial function will have the highest exponent on the x being an even number. Okay, and what we know about our odd degree functions, things like linear. Linear is odd degree, it's a degree 1. That's our simplest polynomial function with an odd degree. Now what I want you to remember here is linear relationships either look like this. If our slope was negative, we had the line going up to the left and down to the right, or it looks like this. It starts down at the left. It starts in quadrant 3 and goes to quadrant 1, so it's heading up to the right. That's important because it tells us our end behaviors. So this was the one for a negative slope. M is less than 0, and this one here is when our m was greater than 0. It's a positive value. So that's our lead coefficient. Our slope is our leading coefficient value. So when our slope is negative, the ends go from quadrant 2 to quadrant 4, and when our slope is positive, or the leading coefficient is positive, we went from quadrant 3 up to quadrant 1. The same is true with your cubic. If your leading coefficient is positive, you're going to start down in quadrant 3 and head up to quadrant 1. If your cubic has a negative leading coefficient, you're going to start in quadrant 2 and head down to quadrant 4. So that's why it's important to know your whether you have an odd degree function, your end behaviors will be opposites, and then the leading coefficient tells you which way the n behaviors go. With an even degree polynomial, if you think of your quadratic, if your leading coefficient was positive in the quadratic, you had this smile, it was happy, you were positive, it's opening up. Or if it was a negative lead coefficient, it was a frown and it was opening down. So with even degree polynomials, your n behaviors will be the same. They're either both going to positive infinity or both going to negative infinity. So this, again, if your leading coefficient was positive, so your n, that's leading coefficient, is greater than 0, you're going to have the n behaviors going both to positive infinity. If your an, your leading coefficient, is a negative value, you're going to have your parabola or even degree polynomial having its n behaviors go to negative infinity. So if you have a quartic, sometimes you get little bumps in between, but if you had a positive lead coefficient with a quartic, you might have something that looks like this. Sometimes they're W-shaped like that. If you had a negative lead coefficient, you could end up with your quartic looking something like that, but your n behaviors are what is important here. So based on your degree and your n behaviors, you should predict leading coefficient, not your n behaviors. Based on your degree, whether it's even or odd, and whether your leading coefficient is positive or negative, you can predict what those n behaviors are going to look like. So on your summary sheet, if you need to add a little more information to that, please do. You want to talk about these things potentially being your leading coefficient values, positive versus negative, to help you know what your n behaviors are going to be. I might also add in a little note about what the n behaviors are. It's just what's happening as you look to the very left of the graph and as you look to the very right of the graph. What are the y values tending towards? They will tend to either positive infinity or negative infinity. All right, I have a quick example here where we're going to just state the degree and then the n behaviors. And I'm just going to use the Q notation for these, Q1, Q2, Q3, and Q4, just because it's so much quicker to write. So looking at the very first one, I wrote this one in descending powers of x. I've got a 5x to the 4 minus 3x to the 3 plus 8. So my degree, that's a hard thing to see that was actually a 3 there. My degree here is 4. So I have an even degree. That means my n behaviors have to go the same direction. And because my leading coefficient is positive here, so degree is 4, positive lead coefficient, it means my n behaviors are going to look like a parabola that opens up. So I'm really going from Q2 to Q1 with my n behaviors on that one. All right, looking at the second one here, the highest exponent on the x is the 3, so this is a degree 3. And I just realized I didn't write on the number on this one, so this was a degree 4. Degree 3 for this one, so that means my n behaviors are going to be opposites, and because the sign of my leading coefficient here is a negative, I have a negative sign here, it means it's going to look like a line. Degree 3 is odd, so I think of my linear relations. If I had a line with a negative slope, I would end up going in that direction there. So I'm heading from Q2 down to Q4, quadrant 4. And looking at this last example, if I look at the degree here, it's a degree 5. Should use a different color. Degree 5. And I didn't get another color, but that's okay. Degree 5. So again, it's odd degree. And I know that's like a line, and my leading coefficient is negative again in this case, negative lead coefficient. So again, my n behaviors are going to be Q2 to Q4 in terms of what that graph looks like. So you should, even if it's not written in descending powers, you should be able to identify your degree, the sign of the leading coefficient, and use that to help you predict what those n behaviors are. That is a goal.